Okay, so I have a question here, but I'm not going to do the whole question because the purpose of this video is to show you how to finding the general term, which might be called Tn, of a quadratic. Can't spell. Okay, so I'm actually just going to do the last question. Now I might end up doing the others in order to get the last one, if you know what I mean. But yeah, okay. So a couple of steps to this, five I think. So the first step is to find a. Okay, so it doesn't say it in this question. It does sometimes. In this particular question, it doesn't. But the general term of a quadratic sequence has a structure, and it always has the same structure. So it's an squared plus bn plus c. And to find the general term, essentially what we have to do is find the numbers for a, b, and c. And then we have it completed, so we kind of have to fill in the blanks. Okay? So the way we find a, and this kind of needs to be, this part needs to be remembered, is we let 2a equal the second difference. Okay, so we need to find the second difference. So this sequence is made out of a pattern. So the first bit of the pattern has 4 squares, then 9 squares, then 16 squares, then I'm assuming 25 squares, 36 squares, and so on. Okay, the first difference of this pattern is plus 5, then plus 7, plus 9, plus 11. So that is not a common first difference, which we expected. So we look at the second difference, which is plus 2, plus 2, plus 2. Okay, so that's a common second difference. And then to find a, like I said, we are going to let 2a equal the second difference, which in this case is 2. And then we're going to isolate a, so we solve for it. So I was going to divide by a. So we're going to divide by 2 and divide by 2. And we get that a equals 1. Okay. Right, so now what I'm going to do, and you need to remember this step, right, is that you're going to write the general term again, except filling in the a. So I'm doing it over here. So it becomes 1n squared plus bn plus c. Okay, so now I have the a filled in there because I got that a was 1, and I only have to solve for b and c. So to solve for b and c, because they're 2 variables, we need 2 equations. Okay, so step 2, we're going to find an equation using n equal to 1. All right, so we get c1 is 1 times 1 squared plus b times 1 plus c. So that's replacing every n with a 1. Now, this one I know confuses students sometimes. So what that means is the value of the first term. Okay, so if we scroll back, the value of the first term in this sequence is 4. So I'm going to replace that with 4. We're going to do the maths on this one. So when you're doing this maths, you need to remember BIMDAS. Okay, so brackets, there are no brackets because brackets in BIMDAS are a sum inside a bracket. Okay, so I know we have a bracket, but there's no sum inside that bracket. So in this context, we don't have a bracket. So then you move on to I, and I is indices, and we do have an indice. So we're going to do that bit first. So I'm going to do this here. So I'm going to leave the 1 alone, that's on the outside, and I'm going to do 1 squared, which gives me 1. Then b times 1 is just b, and then c. So then I have 4 equals 1 times 1 is 1 plus b plus c. And then I'm going to do letters on one side, numbers on the other. So I'm going to, this is a plus 1. I'm going to minus 1 to get rid of it and move it over the other side. So that gives me 3 equals b plus c. Okay. And then the third step, I'm going to find another equation. I know you can't see this writing, hang on, using n equals 2. Okay, so this equation that's here has 2 variables and just 1 equation, so I can't solve it. To solve an equation with 2 variables, you need 2 equations. So I'm going to now use this to get a second equation. Okay, so this time, where's my little, there. Okay, so I'm going to use this, and I'm going to make all the n's 2 this time. So that will be t2 plus 1 bracket 2 squared plus b times 2 plus c. Okay, so I made all the n's 2. Again, remember that this means the value of the second term. So if I go back over the value of the second term, there it is there, it's 9. So I'm going to replace that with a 9. Sorry, I don't know why I had a plus there, equals. So again, same logic applies here. We do the indices first. So it's 1 by 4. Sorry, 1 by 4. B by 2 is 2b, and then plus c. So 9 equals 4 plus 2b plus c. And then again, letters on one side, numbers on the other. So my plus 4 I'll get rid of with a minus 4. Minus 4 on this side. So 5 equals 2b plus c. Alright, so now I have 2 equations. There you go. With the same 2 variables, which means now I should be able to solve it. We solve it using simultaneous equations. So use simultaneous equations to find b and c. Okay, sorry, I'm writing this off your screen as well. So I've created step 4, use simultaneous equations to find b and c. So the first equation is b plus c equals 3. And the second one is 2b plus c equals 5. Okay, so we need to cancel one of the lines. I'm going to cancel the top line. So I'm going to multiply this by minus 1. So that whole top line gets multiplied by minus 1. So the b gets multiplied by minus 1, that's minus b. The c gets multiplied by minus 1, that's minus c. And 3 gets multiplied by minus 1, that's minus 3. Yeah? Whole bottom line stays the same, so 2b plus c equals 5. I am going to cancel off my c's because I have a plus c and a minus c, which is 0. There's an invisible 1 in here, so 2b minus 1b is 1b, which is just b, and 5 minus 3 is 2. And then we sub to get the other one, so I'm going to use the top line. So I'm going to go b plus c equals 3. I'm going to take this and put it in for b. So it's 2 plus c equals 3. And then isolate the c, so minus 2 minus 2. So c equals 1. Okay, so I'm going to put my final answer in. I have Tn equals, where am I after putting that now? Oh, there, sorry. So what I was trying to fill in was an squared plus bn plus c. I got a at the beginning to be 1, so 1n squared. B there is 2, so plus 2n. And c is 1, so plus 1. And there is my final nth term for the quadratic sequence that was made by these shapes. Okay, so that's how you do the general term for a quadratic sequence.